Hello everyone, this is example number 2, and now we have a data set that does not start from 0 but it starts from a greater integer like 20, 15, etc. This can be any number. And again, y is a function of x, so we have to put x here and y here. Usually, what we do, we put the independent variable, the free running variable here, and the dependent variable which depends on this independent variable here, y. Like I gave the example of distance and time graph, like how much distance someone is covering with respect to time. So let's first plot the axes. Okay, these are the axes, and we put 0 here. This is the origin. But as you can see, if we put numbers on the x-axis like this, 0, 5, 10, 15, 20, 25, 30, 35, 40. And on the y-axis, we put numbers like 5, 10, 15, 20, 25. First coordinate, which will be 20, comma 15, will lie here. 20 would be here and 15 would be here. So it will be like this. And the last coordinate, which is 40, comma 23, would lie somewhere here. So one more thing. Since these are 5 divisions and we have a gap of 2 between 21 uh, and 23, as we can see in a data set. So where would 23 would lie? Between 25 and 15, I would be having 20 divisions, 10 in the upper part and 10 in this lower part. So instead of having 10 divisions from for a difference of 10 numbers, I have 20 divisions. So for such a least count, which could be easily evaluated like this, we have 10 divisions from here to here, and the quantity we are having on the y-axis have a difference of 5. So 10 upon 5 is 2. So two small divisions uh, equals to 1 unit on this y-axis. So instead of having divisions like 1, 2, 3, 4, 5, 6, 7, 8, 9, and this would be 10th, we would be having something like this. 2 would be 1, and 4 would be 2, and 6 would be 3, and 8 would be 4, and then this 10th would be 5. So we would be having 25 here if 20 is starting from here. This will be 21, 22, 23, 24. So this is how we are going to plot our data. The sixth division that would be lying here is the point where we will be plotting uh, the number 23. Similarly, here we have 17. So 17, where would 17 lie? 17 is 15, 16, 17. So it has a difference of 2. The difference between 17 and 15 is 2, and our least count is 2 here. So we actually this is not the least count, this is the scaling factor, how we have scaled our graph. So we multiply by 2, so this gives 4. So the fourth division here, like 1, 2, 3, 4, fourth division would be 70. So the next number will lie here. Similarly, it's 13, 19. 19 would be two small divisions down. Here would be 19. So this coordinate would be 30, 19. Similarly, what would be 21? 21 would be here. 35, 21 will lie here, and 40, 23. 40, 23 would be here. 1, 2, 3, 4, 5, 6. So this sixth would be coordinate 23. So this is how the graph would look like. But as you can see, we have wasted a lot of space here, and a lot of space here too, and down here too. So our actual plot just occupied this much area, and a lot of area is wasted. So what we do actually to utilize all this area, we just use the kink sign. I have told in the very first video that there is a sign known as kink sign and we can use that kink sign to stretch our axis. I'm going to erase a part near 0 on the x-axis and draw the kink sign, which is like this. Similarly, I'll be erasing some part on the y-axis and draw the kink sign like this. Okay, so it looks like these axes have been folded down, and 20 can start from here. The number 20 can start from here. So here are all the numbers that are hidden from 0 to 20. This is the range from 0 to 20. We have folded that part, and we can continue from 20 here. Since we have 20 and our last is 40, what we can do, instead of uh, putting numbers on the x-axis like 20, 30, 40, this won't be of any use. We can do it like 20, 30, 40, and I think we still have a lot of space. So what we can do, we can do it like 20, 30, and 40. So this would be 25, this would be 30, and this is 35. Well, what is important to remember here is we make separations in multiples of 2 or 5 only, because when we divide a number by 3, we got non-terminating decimals, like 1 upon 3 is 0.333333, and it doesn't end. So we do not use this kind of separations where we write 20 here and 25 here, because then we would be having 30 divisions, and it will be hard to uh, put a number 22 here on the number line. We try to use multiples of 2 or 5 here, separations of 2 or 5. Like between 20 and 25, I have used a separation of 2 blocks instead of having 3 blocks, and between 20 and 30, I'm using a separation of 4 blocks and not 6 or 9, etc. Similarly, on the y-axis, if I put numbers like this 15 and then 20 and then 25, I won't be using a good amount of space. What I can do is 15, 20, and 25. Yeah, that would be fine. So this is 20 and this is 25. So now we'll start plotting. So the first coordinate is 20, 15. So here's, so 4 divisions on the y-axis is equivalent to 1 unit. So 1, 2, 3, 4. The fourth point would be 16. Similarly, 5, 6, 7, 8. Eighth point would be 17. And then 9, 10, 11, 12. 12th point would be 18. And then 13, 14, 15, 16. 16th point would be 19. And then 17, 18, 19, 20. See, 20th part would be 20. So what we had to plot? We had to plot 25, 17. 25 is here, and where would be 17? 17 would be between 15 and 20. And what's the difference between 15 and 17? 17 minus 15 is equals to 2, and we have 4 divisions for each count on the y-axis. So 4 into 2 equals to 8. So the 8th division here, 1, 2, 3, 4, 5, 6, 7, 8. 8th division on the graph paper would be number 17. So we would be having our coordinate here on the 8th division. This would be 17. The next number is 19. So 19 would be 4 divisions down 20. And here is 30 on the number line. And 1, 2, 3, 4. 4 divisions down would be 19. Since 20 is one number less and we have a scaling factor of 4. Similarly, for 35, 21, 21. So 1. For 1, we again have to count 4 divisions. So here would be 35, 21. And the last coordinate is 40, 23. 40 is here on the line, and where would be 23? So since this is 20, 20 and 23 and 20 has a difference of 3 and 3, 4 goes 12. So it's 10, 11, 12. Here would be our number 23. So this is how you plot a graph that does not start from origin but from some other number, and how you scale your x and y axes. So y axis is here and x axis is here. One important thing you need to mention while plotting your graphs is the scaling factors. So you mention those scaling factors at the top, like at x-axis. So at x-axis we have a difference of 5, and this would be equivalent to 2 centimeters on standard graph, because 1 centimeter here and 1 centimeter here. So 2 centimeter equal to 5 units, and 1 centimeter would be equal to 2.5 units. So you can write it both ways. I'll be writing it like this, that 1 centimeter is equals to 2.5 units. Units of the quantity you would be having here. For example, if it's time, so and time in seconds, each centimeter on the x-axis will be equal to 2.5 seconds. Similarly, on y-axis, if we have speed, and this is some acceleration graph, so we have speed on the y-axis. So how will write this? So at y-axis, 1 centimeter means this division. So again here also 1 centimeter equals to 2.5 units, or when we know actually what quantity we are plotting, we can use the actual units of that quantity. So speed, if we are measuring it in meter per second, so it will be 2.5 meter per second. Okay, thank you and have a nice day.